Hello friends, welcome to my YouTube channel. Now we will start the previous AE Electrical question paper of Telangana Generation and Distribution Corporation Limited paper. So we'll start the first question here. That's the question. It is a series RL circuit having resistance of 20 ohm and inductance of 8 Henry is connected to a DC voltage source of 120 at t is equal to 0. The current in the circuit at t is equal to 0.6 seconds is. So we will take the first given data. So as per the given data, there is a RL circuit, there is a resistor as well as one inductor. So resistance is of how much? 20 ohms, inductance of 8 Henry, which is connected with a voltage source of magnitude 120 volts, and they given a switching instance here at t is equal to 0. It is closed, right? Now what we need to find here, it is I need to find the current at t is equal to 0.6. That means after the instant of switch is closed, we need to find the current. So the formula for this current is I of t is equal to, so Vs by R into 1 minus e power minus t by tau here. So let us calculate what is the t value. So t earlier specified in the given data as 0.6 seconds. Now the time constant tau is equal to L by R. What is the L inductance? L is 8 divided by R value is 20. Now we'll substitute this data in the equation. We'll get the answer as I of t is equal to, now Vs is nothing but 120 divided by R value is at 20 into 1 minus e power minus t. What is the t value? It is 0.6 divided by 8 by 20 tau value it is. Okay, so if you further simplify it, 6 into 1 minus e power minus, okay, so 12 by 8. Again further simplify this one, we'll get the answer as 4.66 amperes is the answer. Okay, so next question we're going. The next question is, when an alternating current passes through a ohmic resistance, the electric power converted into heat is. So when the current passes through any resistive element, it produces a heat, that is P is equal to I square R. If you take energy, H is equal to I square RT joules. Here whatever you are giving, it is nothing but electrical energy, and we are getting the output as heat energy. Okay, so heat energy is nothing but the, if you talk about the power, it is nothing but true power, or it is also known as real power. Okay, or it also known as active power. Okay, so among the given options, the true power is the answer. So apparent power means it is S, reactive power means Q, true power means P. So if they ask about the relationship between these things, we can write it as S is equal to square root of P square plus Q square. Okay, next question. Next question, it is the intrinsic impedance of free space is. So what is the meaning of this intrinsic impedance? It is the impedance of wave traveling in a medium of air. That means the wave traveling in a medium of air here. So it is a resistance or impedance offered to this wave here. So generally it is 377 ohms. Okay, so answer is 3 here. And additional information is intrinsic impedance given by eta, which is equal to electric field intensity divided by magnetic field intensity H, or which is equal to square root of permeability by permittivity. Okay, next question. Next question, with E in Z direction and H in minus Y direction, so the minus Z and minus Y direction, the direction of the propagation of electromagnetic wave will be in? So let's take here. So this question already discussed in my previous videos. So we will take x direction and we will take y direction here, and finally we will take z. So y here and here it is z. So minus y means here and minus x means in this direction, and minus z is in this direction here. Now the electromagnetic waves travel in a direction which is perpendicular to both electric field intensity and h. So the perpendicular direction will be here minus x direction. Why? Because in minus z direction, what is there? It is E. Okay, and in minus y direction it is h. So in perpendicular, these two are perpendicular means it is in minus x direction. Next question. Next question here. The velocity of electromagnetic wave through an dielectric is, the formula generally used for velocity of electromagnetic wave is V is inversely proportional to square root of sigma r here. What is sigma r here? It is permittivity. Okay, so permittivity is equal to epsilon naught into epsilon r. So it is epsilon. So epsilon naught into epsilon r. So epsilon naught is nothing but absolute permittivity, and epsilon is relative permittivity. Okay, so relative permittivity for air is equal to 1. Okay, now it is they are asking for dielectric medium. So for dielectric, epsilon r is greater than 1. So as it is greater than 1, so V is inversely proportional to square root of epsilon r is a high value, so velocity is less. So the velocity of vacuum or air is greater than velocity of dielectric. Okay, so the answer is the velocity of electromagnetic wave through a dielectric is lower than in free space. So velocity in free space right here. So next question. Next question from the transformers. Here in the equivalent circuit of transformers, the magnetic circuit branch is drawn in parallel to the supply voltage. So generally by conducting the open circuit test, we can find the shunt branch parameters. Shunt branch parameters we can calculate. So based on that shunt branch parameters, we can draw the equivalent circuit with the help of resistance and inductance to represent the magnetizing component of current and working component of current here. Okay, so as we know, the core losses is nothing but constant losses, depends upon the supply voltage and frequency. Okay, so this is nothing but open circuit test we are going to perform for finding constant losses. So constant losses are nothing but it also known as core losses here. Okay, the transformer's magnetization current and iron losses remain constant with the supply voltage. That means as VL is going to be changes means automatically is going to change. But as soon as the VL is a constant, these two losses also remains constant here. That's why we are representing them in parallel. Suppose if they ask for series branch parameters means this depends upon the current carrying capability. Okay, so these are nothing but series branch. Okay, so next question. And next question is a doubly excited silent pole motor will have. So generally there are two types of motors in synchronous machine, silent pole and cylindrical pole. The speciality about silent pole it is the torque developed in this salient pole machine is depends upon two things, two torques, that is nothing but reluctance torque plus we can call it as a mutual torque. Okay, so let's have a small discussion about this reluctance torque plus mutual torque. Okay, so here the reluctance torque is present even the excitation is going to be 0. Okay, the mutual torque is present when excitation is present. Okay, now even the excitation fails, the torque developed by the machine is not going to be zero, it is present because of this reluctance torque. So that is a speciality of this silent pole machine. Excitation, if you make it zero also, okay, excitation if you make zero also, some present torque is present, that's called reluctance torque. So reluctance torque followed by mutual torque. Okay, so the mutual torque depends upon the excitation you are giving, and reluctance torque is independent of the excitation. That is why even if you are not giving excitation also, the machine starts rotating, not at synchronous speed, lesser than that speed. Okay, so answer is 4 here. Next question. Next question. During constant torque operation of AC electrical machines. So AC electrical machines here. So let us take any machine formula. For example, the simplest one is a transformer. So EMF generated is equal to 4.44 into F is the frequency into, so B into A into number of turns here. So from this what you can write, 4.44 into F into 5 into N here. Okay, so E is proportional to, if you take the 4.4 is a constant, number of turns are constant here, so F into 5 here. So 5 is proportional to E by F. So we can write this one as B maximum. So B max is proportional to 5 here. So maximum flux density is proportional to EMF divided by frequency. You can also treat this one as V by F. For any electrical machines, the maximum flux density depends upon its core. So once the core is designed, we cannot change this. So here for multiple operation purposes, we can change the voltage along with the frequency, but it should remain constant only. It should not change. You can vary the frequency, you can vary the voltage to control purpose, any electrical machine. So both supply voltage and supply frequency has to remain constant. So the ratio of V by F is should be remains constant for any electrical machine operation. Okay, that is also for constant torque operation here. Next question. Next question here. In a 3-slip ring induction motor, if the rotor resistance is changed, then what is going to happen here? Okay, so we know that the maximum torque, so the maximum torque limit changes, the speed of the maximum torque, the iron loss changes, and they are asking about the torque here. So S max is equal to rotor resistance R2 divided by rotor reactance X2 here, and we know that the maximum torque is the depends upon voltage, the rotor EMF divided by the rotor reactance here, and it is independent of rotor resistance R2. Okay, now the maximum torque can be obtained by changing the reactance but not the resistance here, but the maximum torque at which slip we can change it. That means here if you want maximum torque at a particular slip, I can change, right? The speed at which maximum torque occur changes, but it does not depends upon maximum torque. Okay, understand? Hope you understand this. Okay, so the speed at which maximum torque occur changes, at which here important. Okay, so the answer is 2. Next question. Next question here. The synchronous generator and synchronous motor under over excited condition. So remember this, the V and inverted V curves of generator and motor. First of all, let me take, it's about generator. Okay, so here in x-axis we can take the excitation. So in y-axis I can take power factor and current here. So if let us draw these curves V and inverted V curves here like this. So as you can see here, so this is specifies the power factor and this specifies the current here. Now the excitation is depends upon three ways. Normally, first one it is under excitation here, and here normal excitation, and here it is over excitation. Now in a under excited condition, uh, generator operates at leading power factor. Under over excited condition, it is acting as lagging power factor. At normal excitation, it is under UPF, unity power factor conditions. Now the synchronous generator and the synchronous motor under over excited condition. So over excitation condition, if you talk about the generator, it is at lagging power factor. Suppose if you talk about motor, so if you talk about motor, it's a reverse here. So motor means here it is lagging, and UPF remains same, and here it is leading power factor. Now you can say the answer for this question. Under over-excited condition, generator acts in lagging power factor current, and the motor is at leading power factor current respectively. So answer here it is 2. Next question. Next question. The presence of earth in case of overhead lines. So presence of earth in overhead transmission lines. So here let's assume it's earth, and let us assume here we have a transmission tower. Okay, so because of it we are having a transmission line like this, right? So just assume it is. So because of this transmission line, it's a conductor, and ground it also a act as a conductor. Okay, now between these two conducting bodies, there is a air act as a dielectric medium. So here it acts as a air. So air act as a dielectric medium. So two conducting bodies separated by some dielectric medium is nothing but capacitance. So C is equal to epsilon naught epsilon r into A by D. So as the area is more, automatically capacitance also more. Okay, so the presence of earth in case of overhead lines. So presence of earth means this is nothing but a conducting body here. So top and bottom. So automatically it's going to increase the capacitance, right? Next question from the power systems. For the stability and economic reasons, so we operate the transmission line with a power angle in the range. So P is equal to EV by X into sine delta. So where the maximum angle of the load angle is 90 degrees. Actually, it's the maximum value. But for stability reasons, so we may operate it from 30 to 45 degrees to avoid instability conditions here. So if you want more details, you can go for swing equation. Okay, or you can go for more. If you want more information, you can go for equal area criteria of power system stability. Then you will understand this question here. So remember this. So 30 to 45 degrees is a value of delta. Next question here. It is an alternator having an inductance EMF of 1.6 per unit is connected to an infinite bus of 1.0 per unit. If the bus bar reactance of 0.6 per unit and alternator reactance of 0.2 per unit, the maximum power that can be transferred is given by. So here we have an alternator, so which is having a reactance. Okay, so EMF is E is equal to 1.6 volts, and it's having a reactance of how much? Reactance is 0.2 per unit. Okay, now it is connected to a bus bar. The bus bar is operating at a voltage of V is equal to 1.0, and it is having a reactance of how much? It is 0.6 here. Okay, 0.6. Now the maximum power that can be transferred. So we have seen the formula. So P is equal to EV by X into sine delta. So P max occurs, so at delta is 90 degrees. So we seen the formula here. Let's consider this case. So P is equal to EV by X. So it is a maximum condition. Now here E is nothing but 1.6 and V is how much it is 1.0 divided by the reactance. So total reactance xt here. It is nothing but sum of alternator reactance plus sum of busbar reactance. It is nothing but 1.6 divided by 0.6 plus 0.2. So 1.6 by 0.8 is nothing but how much? 2 per unit. So the power transfer is 2 per unit here. Next question. Next question. An overhead line with a surge impedance of Z is equal to 400 ohms is terminated through a resistance R. Sorry, resistance of R. So this is a Z and is terminated with a R value. Okay. A surge traveling over the line does not suffer any reflections at the junction. So this junction here, there is no any reflection here at the junction if the value of R is. So this is a simple formula. If you want no reflections, so no reflections means whatever the impedance of the transmission line, the same impedance has to be terminated here. So Z is equal to R is equal to, so 400 ohms means there is no thing to discuss about no reflections. So here among the options is the answer is 400 ohms, which is nothing but none of the above. Next question. The self GMD method is used to evaluate the form. So generally inductance L is equal to 2 pi into 10 power minus 7 ln of, so GMD by GMR we can write here. So what is GMR? Generally we write R dash here. So R dash is nothing but 0.7788 R. Okay, so this is the important formula in case of inductance. Okay, if you take the same formula for capacitance, we will use only GMR here. They generally actually take the conductor radius. Okay, so the self GMD method is used to evaluate inductances only, not capacitances. Okay. Okay, next question. Three insulating materials with the breakdown strength of 250 kilovolts per centimeter, 200 kilovolts per centimeter and 150 kilovolts per centimeter, and the permittivities of 2.5, 3.0 and 3.5 are used in a single core cable. The factor of safety for the materials is 5. The location of the materials with respect to the core of the cable will be. So here the electrostatic stress is more on the surface of the cable conductor. So electrostatic stress is more at the surface of the cable. So the conductor is having more electrostatic stress here. Okay, so if you want to use the permittivity, which should be highest here at the surface of the cable. So the location of the material with respect to the core of the cable will be the first one highest. So in the given options, highest permittivities is having 3.5. Later we can use, on that we can use 3.0, after that 2.5. So here we should keep the highest permittivity. So the answer is 3.5, 3.0, 2.5 is the right. Next question. Next question from the power systems, it is the corona losses increases with. So the corona losses is given by Peake's formula, which says that PC is equal to 243 into F plus 25 divided by the delta into square root of R by D into V naught minus VPH whole square into 10 power minus 5 kilometers. So kilovolts per kilometers per phase. So from this relationship, the PC is proportional to F plus 25. As your frequency increases, the corona loss also increases, right? And remember that the PC is not equal to 0 for DC supply. It is an empirical formula. Next. Now, so PC is proportional to square root of R by D here. So R is the radius of the conductor. D is the distance between the conductor here. Okay, so diameter of the conductor here. Now, so PC is going to inversely proportional to R by D, but here we should remember the one point that the V naught is depends upon, sorry, VPH depends upon this diameter here. Okay, now as VPH increases, automatically what will happen, this total term is going to be decreases. Finally losses are going to be decreased. So don't confuse with this T and D here. Okay, now so from this we can say that increase in supply frequency but reduction in conductor size, right? Next question from the power systems. If the inertia constant H of a machine of 200 MVA is 2 per unit, its value corresponding to 400 MVA will be. So remember that the inertia constant H is having units of megajoules per MVA. That means H is inversely proportional to MVA rating here. Okay, so let this MVA rating will be G. So H2 by H1 is equal to G1 by G2. So from this what we want H2. H2 is equal to MVA rating 1 divided by MVA rating 2 into H1. What is the MVA rating 1? G1, it is 200 into H1 is 2 divided by 400 is nothing but 1 per unit. So the answer here it is 3. Next question. The next question is from the power system protection. An overcurrent relay of current rating 5 amperes and current setting is 150% is connected to the secondary of CT of ratio 300:5. Then the current in the lines for which the relay pickup. Now the formula for the relay pickup is relay pickup is equal to current setting into CT ratio. Okay, as we know the current setting is, the relay is set for 5 amperes. So 5 into, it is set up to 150%. So 150 divided by 100 into the CT ratio is 300 divided by 5. So 5 gets cancelled, 100 300 gets cancelled. So 3 into 150 is nothing but 450 amperes is the answer for this question. Next question is from the control systems. For the characteristic equation, they have written h square plus 4.8 s plus 72 is equal to 0. The damping ratio and the natural frequency are respectively. So if we compare this equation with the standard equation, second order equation, h square plus 2 zeta omega n s plus omega n square is equal to 0. If you compare these two equations, we can say omega n square is equal to 72. That implies omega n is equal to square root of 72. So which is nothing but 8.485. Okay, so radians per second. Now we want comparison this. So by comparing these two terms, what you can get, 2 zeta omega n is equal to 4.8. Now zeta is equal to 4.8 divided by 2 into 8.485. So by comparing this, the answer we got is 0.2828. So approximately 0.283 here. So from this, there are two options matches with the option 2. So 0.283 and 8.48 radians per second. So here I forgot, radians per second is the answer for this question. The next question, in RH criteria, if all the elements in a row are 0, then these are the there may be the poles of equal roots and opposite side may be there, or the poles of conjugate roots on imaginary axis, or the conjugate roots forming a quadrate in the S-plane. So these three options are correct options. Okay, so the answer is all of the above. Next question, a network has a pole at s is equal to -1 and 0 is equal to s is equal to -2. The network is excited by sinusoidal input. The output will be, so first of all, let's take the here. So here we have the real axis and here we have j omega axis, right? Now first we have a pole at s is equal to -1. So we are having a pole s is equal to -1 and 0 at s is equal to -2. So here the pole is nearer to origin. That means it is a lag network. Okay, so once it represents lag network, the sinusoidal input, the output lags the input here. Okay, next question from digital electronics, the code used to reduce the error due to ambiguity in reading of a binary optical encoder is, the answer is a gray code. Why it is gray code? It is also known as reflected code. It is also known as reflected code. So why it is called gray code means it is a binary representation of a decimal digit which has a change in 1 bit position. So there is a change in only 1 bit position. Okay, 1 bit position. So what is the use of this change in 1 bit position? Okay, if there is any error in the code, we can at least assume that there will be only 1 bit position change. Okay, so 1 bit position, so it is used to reduce the error in communication systems. So communication systems such as TV and mobile. Okay, so it is used to reduce the error. Next question, it is a decade counter requires, so decade counter is also known as mod 10 counter, which requires 4 flip-flops. Okay, so 4 flip-flop means 2 power 4 is nothing but 16. So mod 10 means more than more than 8. So for if your 2 power 3 means it is 8. Okay, but it's a decade. So decade means mod 10 counter which requires 4 flip-flops for their operation. Okay, so the answer is 4. Our next question is from Tangentco A electrical paper 2018 is humming code is. So actually what is a humming code? It is a set of error correction codes that can be used to detect and correct the errors that can occur when the data is moved or stored from the sender to receiver. So as per this, the humming code is nothing but it's an error correction code system. So it is invented by R.W. Hamming. So R.W. humming. So because of his name, it is known as humming code. It is used for error correction code system. Next question. Next question is from the control system, microprocessor. In microprocessor architecture, the flag indicates, so generally the flag indicates the internal operation results. Suppose we have zero flag, parity flag, flags are there. So these flags are set and reset. It states that the internal status of the CPU, internal status of the CPU. Okay, next question. The next question, it is from the networks. The quality factor of a series RLC circuit with R is equal to 10, L is equal to 25 millihenry, C is equal to 100 microfarads is. So let us take the formula for quality factor when the RLC network is in series connection. QS is equal to 1 by R square root of L by C. So as per this formula, directly substitute the values. R is nothing but 1 by 10. So R is equal to 10. Square root of L is nothing but 25 milli means 10 power minus 3 divided by C means 100. Micro means 10 power minus 6 farads. So if we solve this, we may get 0.1 into 15.8. So 15.8 into 1, 0.1 means 1.58 is the answer for this question. Okay, next one. The next question, the reactive power of a balanced delta connected load fed from three-phase 400 volts system, the phase current is 20 amperes and the load factor angle is 40 degrees, lagging is. So here we need to find the reactive power. So Q is equal to root 3 into VL into IL into sine phi. So from this data we can take it as VL as how much? 400 volts, and IL in this formula we can take it as 20 amperes. So don't confuse here with the, by using star and delta connections. Just let it be here IL. Okay, or if you want to, you can take also VPH, IPH also, no issue at all. Okay, now sine phi. So sine of phi, how much it went? 40 degrees here. Now if we substitute all together here, Q is equal to root 3 into VL is 400 into 20 into sine 40. So if we substitute this, we may get the answer as 8906.728 VAR. Okay, so here the option is not available. Okay, so this is a correct option. Okay, now you may, if you neglect this value, if you neglect this sine 40, if you substitute these things, you may get the answer it as 1. Okay, so but that is not the actual answer, it's a wrong answer. The actual answer is 8906.728 VARs. Okay, make it correction. Next question. The next question from the networks, a simple network given. The voltage across 5 ampere source in the circuit. So here we need to find the voltage across this 5 amperes current source, means the voltage across 5 ohm resistor here. Now for solving this problem, I will take nodal analysis. So by using nodal analysis, it is easier to solve this problem. Okay, so simply here I will take the nodal voltage VA and we will choose this as a reference here. Now by applying KCL and Ohm's law, okay, by applying KCL and Ohm's law, I am going to write. So the first one is VA, here plus minus means VA minus 10 by 5 ohm resistor is nothing but the current, plus the current leaving all these directions, here it is entering, plus VA by 5, and current entering is treated as minus sign, so minus 5 is equal to 0. So 2 VA by 5 is equal to 7. So VA is equal to how much? 17.5 volts is the answer. So answer here it is It is 2 is the right option for this question. So we'll go for next one. Next one. A transformer operates most efficiently at 3 by 4th full load. So X value given as 3 by 4th and it is operating at more efficiently. Its iron losses and the full load copper loss available. So the condition for getting maximum efficiency is at a fraction of load X is equal to X square is equal to, so P const losses are iron losses divided by PCU. So X value already given. So Pi by PCU is nothing but X is nothing but 3 by 4 whole square is nothing but 9 by 16. So iron losses by copper losses. That means it's the ratio of iron losses to copper losses to get the efficiency maximum will be this one. So answer here it is fourth one is the right option. Next one. Next question. This question we already discussed in this lecture. Again we are going to repeat from the V and inverted V curves. A synchronous generator is feeding power to infinite bus bar at unity power factor. If the excitation is now increased, it will deliver. So again, let us draw the inverted and V curves of alternator. So here we know it's operating at leading at under excitation. Normal excitation is at center and over excitation here. So it is excitation. Now in these curves, this is the power factor and this is the current. A synchronous generator is feeding power to infinite bus at unity power factor. Now if the excitation, now here it is UPF. Now excitation is going to be increases here. Okay, as it's going to excitation increases, here the machine is going to operate at a lagging power factor. So among the given options, so this is the right option which says that same power but it is operating at lagging power factor. So based on the options, second one is the most appropriate answer. And one of the most important fundamental questions and very important questions asked in most of the PSUs is based on the one formula. I will tell you that formula. The per unit impedance value of an alternator corresponding to base value of 13.2 kV and 30 MVA is 0.2 per unit. The per unit value of impedance with respect to the new values of 13.8 kV and 500 MVA will be. So the formula here it is X per unit new is equal to X per unit volt into, so MVA new value divided by MVA old value into kV base of volt divided by old square divided by kV base new square. So based on this formula we can substitute the values here. X per unit is 0.2 into MVA new. What is that? How much MVA new? New value is 50. So 50 divided by MVA new is, it is only 30 into KVB old value. Old value is the previous value. How much it is? 13.2 divided by new value is 13.8. I can take it as a whole square. So if you solve this, you may get it as 0.03. That's wrong. Let me correct. So 0.305 per unit is the answer. So this is the right answer. Next question. Next question is from the control systems where it is asked the steady state error of type 1 system for unit step input. So this is also one of the important question. So let us take the steady state error and here going to take type. So type, okay. So if you take type 0, type 1, type 2 errors for different inputs, that may be a step, a ramp, parabola. So here we have 1 by Kp, that is a Kp is a position error constant, and here we have 1 by kv, and here we have 1 by ka. So velocity error, velocity constant, and here we have acceleration constant. So after here the error is going to be infinity, infinity, here 0, infinity, 0, 0 here. If you take type 3 all are zeros only. Now the steady state error of type 1. So type 1 is given, and for unit step input. So step input means this is step input here. So it is going to be 0. So answer here it is 3. Okay, next question. And next one is a straightforward question. In Bodo plot systems with a data time introduces phase angle of minus WTD into 180 degrees divided by 5 in a phase plot. So this is the answer for this question. Next one. When a line commutated converter operates in inverter mode, that means here the converter is there. So one converter station, when alpha firing angle is less than 90 degrees means this converter station act as rectifier. So when alpha is greater than 90 degrees means it's going to be operating inversion mode or inverter mode here. Now when during this condition, what is happening here? So when this converter act as in inverter mode, okay. So for the inverter, as we know that the input is going to be DC, output is going to be AC. So during this condition, what is going to happen here? So during this condition, it draws the real power from AC supply. So real power where is drawn is from here. So real power from AC supply, and it delivers real power to the AC supply. It draws the real power to AC supply, and it draws the reactive from the AC supply. That means it will going to deliver the real power. It is going to draw the reactive power here. So options are C and D. It delivers the reactive power to the AC supply. It draws the reactive power from the AC supply. That means going to do both the things at the receiving end only. Okay, the option here is C and D is the right answer. Next one. And the next question is from power electronics. A separately excited DC motor, when fed from a single phase full converter, runs at a speed of 1200 rpm. Load current remains continuous if the one of the SCR gets open circuited. So let us take the motor speed will be reduced to. So let us consider a single phase full converter where we have 4 SCRs connected in bridge configuration like this. So here we'll give AC supply between these two supplies here, and here we have R, L, E load. Okay, because it's a DC motor, right? Separately excited motors. Now this is operating here. Now suddenly one SCR goes off. That means the full converter is going to act as a half converter. Okay, so in full converter, let us consider first case. The full converter average, let me take EF average. F for full, EF average is equal to, so 2 Vm by pi into 1 into cos alpha. Now a second case, it's a half converter. That the time formula is E H average is equal to Vm by 2 pi into 1 plus cos alpha. So alpha value is not given. Let us assume alpha is equal to 0. That means 2 Vm by pi, and here it is going to be Vm by 2 pi into 2. So it's nothing but Vm by pi is the average value here. Now we need to find the speed. So we know that EMF is proportional to speed. Okay, so from the formula N is proportional to EP by 5. So we have seen the concepts of DC machines in my previous short notes along with some IES questions. So from this we can say it as, so E2 by E1. So where is E2? E2 is nothing but E with a half wave divided by EMF with a full wave is equal to, so speed with half wave divided by speed with full wave conditions. So we need with half wave. So N H is equal to, so EMF with half wave divided by EMF with full wave into speed with full wave. So what is the EH? EH, it is nothing but Vm by pi. With full wave means we can write it as pi by 2 Vm into N1. So from this Vm gets cancelled, pi by gets cancelled. N1, how much it is? 200 rpm. So 1200 divided by 2, it is nothing but 600 rpm. So among the options, 3 is the right option here with a 600 rpm. Next question. The next question from the same power electronic subject is a three-phase half-wave rectifier with a DC output voltage of 230 volts. The peak inverse voltage across each diode is. So the peak inverse voltage of each diode it is, so peak inverse voltage is nothing but the DC voltage VDC into 2 pi divided by 3. Okay, so there's nothing but VDC is how much? 230 into 2 into 3.14 divided by 3 volts. It is nothing but 481.7 volts. So peak inverse voltage is this value which appear across the diode. Next question. The next question is from the digital electronics. A feature that distinguishes the JK flip-flop from the SR flip-flop is generally in SR flip-flop when both the inputs are 1, so it is invalid condition. Invalid condition. Suppose the same thing in JK flip-flop, so both the inputs are 1, the output will be in toggle mode. So in toggle mode means the output is going to vary from 1 to 0 and from 0 to 1. So it is going to operate high to low like this. So this is a major difference between SR flip-flop and JK flip-flop. Next question. And the next question here it is the minimum number of flip-flops required in a counter to count 60 pulses is, that is, we know that each flip-flop can count up to 2 counts. So each flip-flop can count 2 counts here. Now, so here, so 2 power n, which is equal to 60, approximately 60 pulses we need to count here. So from this formula, n can be treated as n is equal to, so it is going to be 6. Why? Because 2 power 6 is nothing but 64. Here we need to count for 60 flip-flops. Suppose if they ask for example, if they ask for 180 pulses, means at that time n is going to be 8. Okay, so 180 pulses here. N is going to be 8. So next question. And the question here it is, a carrier voltage is simultaneously modulated by 2 sine waves causing modulation index of 0.4 and 0.3. The overall modulation index is, so we need to find the overall modulation index. So overall modulation index, so m, okay, so we can take as a mo. We need to find this one here. So m1 is 0.4 they given with the 2 sine waves, and m2 they given it as 0.3. the formula for overall index, mutual index, is equal to m naught is equal to square root of m1 square plus m2 whole square. So from this we can write what is the m1 value. M1 value known as 0.4 whole square plus 0.3 whole square. So from this we can get the answer it as square root of 0.25 whole square is nothing but 0.5 modulation index finally. Okay. Okay, so for this session it's enough. So thank you friends, thanks for watching my videos. If you like my videos, please subscribe and share and comment. Okay, so in the next session we are going to continue the remaining questions from the TAN-JETCO AE Electrical paper 2018. So thanks for watching my videos. If you like my videos, please subscribe and share, comment here. Thank you. Have a nice day. Bye bye. Take care.